formed by special segments inside of circles. On all of these angle pairs, you want to look for the location on the vertex. So on this first picture, we have a central angle. The reason why I know it's a central angle is because the vertex is located at the center of the circle. If the vertex is located at the center of the circle, this angle, the measure of angle AOB, is equal to the measure of arc AB. So if the angle is 35 degrees, then the arc is going to be 35 degrees. If the angle's 100 degrees, then the arc is going to be 100 degrees. So if it's located at the center, the angle is equal to the arc. So these two angles, even though they're different, an inscribed angle has two chords, whereas this other angle is a chord and a tangent line. What's the same about them is that their vertex is located on the circle. So your vertex is on the circle on both of those. So they're going to follow the same rule. The inscribed angle is the easiest to see. So I've got my angle here. This is angle CAB. Crossed from arc CB. Well, on the previous example, since the vertex was located in the center, the arc was the same size as the angle. On this one, the angle is going to be equal to half the measure of arc BC. So if BC is 10, the angle is going to be 5 degrees. If BC is 30 degrees, then the angle is going to be 15 degrees, half of that. So the angle is equal to half of the arc. On this picture, it's a little bit harder to see because your angle's right here. But where's your arc? Your arc starts at A and it goes to B. So your arc actually starts at the vertex of the angle, even though the angle is CAB. So in this example, the measure of angle CAB is equal to half of the measure of AB. Picture in the circle, we have two angles that are being formed by two chords. When I look here, the vertex of these angles is somewhere inside. It's not exactly at the center. It's just somewhere inside the circle. So anytime you have two chords and the vertex of the angles are located inside the circle, we have to do a little bit more. Well, my angles are right here, angle 1, those two angles. Well, those two angles there are called vertical angles. We know those two angles have to be equal. But those angles are across from two arcs, arc AC and arc DB. These are called intercepted arcs because they're in between the endpoints of the angle. So to find the measure of the angle, so we'll call it angle 1, we have to do a little bit more work. We're going to have to take the two arcs, so measure of arc AC, and add that to the measure of arc DB. And whatever we get with that, we're going to divide the answer in half. So basically, the angle is equal to arc plus arc divided by 2. So this is like your formula here. Last but not least, we've got angles that are formed by either secant lines, a secant and a tangent, or a tangent line. But if I look at all the pictures, the vertexes of all of these angles formed by those special segments are all outside the circle. So the rule outside is kind of like the rule inside, except for instead of adding the intercepted arcs, we're going to subtract the intercepted arcs. So here we just have to figure out where intercepted arcs are. In this picture, my intercepted arcs are DE and CB. In this picture, my intercepted arcs are BD, but the other arc is BC. And then in this picture, my intercepted arcs are from B to C, but then all the way around this major arc, BDC. What's special about this picture is that the arcs equal, when added together, equal 360 degrees. So the rule here is the angle is equal to, we take the arcs, we're going to subtract them. Now if we're going to subtract them, we have to do big arc minus the small arc. We're going to take that answer and divide by 2. So next what I want you to do is try to work on the examples below and then check your answers with the video. We have the vertex of this angle is located on the circle. So the rule is that the angle is equal to half the size of the arc. So we just plug in the angle, which is 3x minus 3, set it equal to half, and what's the measure of the arc? 120. Just work out our algebra. 3x minus 3 equals 60. Add 3 to both sides. We get 3x equals 63. Divide by 3. We get x equals 21. Plug it back in to double check, and we get the measure of the angle is 60 degrees. The second example is a little bit tougher to see, so what I wanted to do is show you. You have your angle right here, angle ABC. The vertex is located on, and the other angle is angle CDA, where the vertex is located also on. But what's special about these two angles is that if I go across and find the arc for both of the angles, the intercepted arc is AC. So if they both open up to the same arc, then these two angles have to be equal to each other. So 10y minus 28 equals 7y minus 1. And you end up getting y equals 9. So if I plug this back, both these angles end up being 82. And we know that the angle is half the size of the arc. So what's the measure of arc AC? Well, it has to be double the angle. So double of 82 is 164. That's going to be in degrees. So in this example, the vertex is located outside the circle. The rule is the angle equals the big arc minus the small arc divided by 2. So my arcs are QS and RS. So if I plug my values into my formula, the angle is x. X equals, the big arc is 174 minus the small arc, which is 98, and we're going to divide that answer by 2. So we end up with x equals 38. So that's the measure of that angle. So the measure of angle RPS is 38 degrees. On the last example, the vertex is located inside the circle. So the angle is equal to half of the two arcs added together. So we're going to take arc plus arc and divide it by 2. So it doesn't matter which angle we pick here, because those are vertical angles and they're going to be equal, but it matters about the arcs. So we're going to go across. My arc is 32 and go across from this vertical angle. My other arc is 100. Throw it into our formula. We don't know what the angle is, so we'll make that x. So x equals the two arcs added together, so 32 plus 100. We're going to divide that answer by 2. So 32 plus 100 is 132, and then we're going to divide that answer in half, so we get 66. So the angle is equal to 66. So angle PQT is 66 degrees. Angle SQR is 66 degrees. How many degrees are the linear pair next to those? We take 180. We subtract 66 from that. We get 114 degrees for both of the angles that are left.